Welcome. I will be starting shortly. Welcome. I will be starting shortly. Welcome to another episode of Microcontrollers with kingernorth. This is episode 16. Today we're going to be doing stepper motors with CircuitPython and Arduino. Please enjoy. Good morning, Walter. Welcome aboard. All right, let's have a look at what we're going to be using today. We got a number of items set up here. It looks a little busy in this picture, but we're going to explain what's going on here. So first of all, we have the Arduino board up here connected to some controls, and this is our stepper motor running over here right now. So that's what we're going to be looking at, and we're going to be using that. We're also going to be doing it on the Feather M4 Express, and it has the same controller board as it does on the Arduino with the same kind of stepper motor down here as well. And they are both actually rotating right now. They are busy doing their thing. A couple of the other things that are available out there, I'm using a small board connected directly to the microprocessor. There are other different types of boards out here. This one's a Cricket from Adafruit. This takes the Feather format of processors. This is a little different than the M4 that I have up there, the Feather M4 Express. This is actually a Bluetooth version. This one actually you can talk to with your phone. But on here, it has, on these pins over here, it has motor connections where you can connect either DC motors or you can actually connect a stepper motor to it. So you have the ability to run it from something like this, which is referred to as a daughter board. And then I have this other one here, which is another Feather board. This is actually a motor driver board. This can drive individual DC motors, up to 4 of them. Or it can drive 2 stepper motors, one connected to each end. And again, it brings its power in from a separate source over here. So those are the different types of devices we have out there. There are others. There's all kinds of little driver boards out there for steppers. This is just a small sampling of what's available. And trust me, it is a small sampling. So let's move these out of the way. And we're even going to move this one over here out of the way. We're just going to slide it out of the way. We're going to leave it connected. And we're going to bring this one into the center of the picture. We're going to show you what's going on here. So what we have going on here right now, and I can probably zoom that in 1 notch, I'm hoping. Let's see if this will be happy. I think we can move this in close enough that we can see everything. And we'll see if that catches on this as it goes around or not. I may have to move it just slightly, just to make sure it stays out of the way. So for now, I'm going to stop this, and then we're going to show how we get to this point. All right, there we go. We're stopped. So we have the Arduino here. We have the stepper control board here, which I will talk about. And we also have the stepper motor itself. This is a nice little item. It's a fairly small motor. It's a considered type of a hobby style stepper motor, but it can be used for a lot of purposes. And I just happen to have a plastic gear wheel on it with an arrow pointing underneath. I actually used this for another project before. So it's something I had left over, and I thought it would be, at least it's an indication to show that it's rotating. So let's take a look at what the stepper motor is. So we're going to have a better look at what's happening there. So this is some detail specs on the stepper motor itself. Basically, what we have up here is, this is the can itself. This is, and it's measured in millimeters in this case. So we have ourselves a small can. It's actually fairly small. It's not too big. It's got a shaft on it that's 5 millimeters in diameter, very common size, with 2 flat sides to it. So you can actually put something down and lock it on with a set screw. But here's the details that we really need to care about right now, with some of the electrical details as well. There's 2 types of stepper motors. There's bipolar, and there's unipolar. Unipolar is the type that we're going to be using for this, and it's going to be the most common one you use for the small hobby motors, and it's probably one of the easier ones to control right out of the gate to get used to. Unipole actually has 4 coils in it, and each one is connected back to a common lead coming back out. So it's 5 wires that we are required to connect when we're doing this, and this is the one we're going to use today, and I'm going to show you how that's hooked up. We get 513 steps per revolution, and basically it's geared down. It's got a gear reduction motor on it. If you notice, that shaft is really offset here. It's not in the middle of the motor. There's a small gear and it turns a bigger gear, which turns another gear, and then eventually it comes out to just over 16 steps per, or 16 to 1 resolution. So 1 to 16 is what it's showing here. So it slows down considerably from what the actual motor's running on the inside. And that's probably a good thing. These are not typically fast motors, stepper motors. These are meant for slow and controlled. And then this one here is 5 volts on this particular one. They also make this exact same motor in a 12 volt version. Either one can be used for this type of experiment. It's got the dimensions in here. It's got how long the cable is. It gives you about a 9-inch cable or 23 centimeter long cable. Actually, it's a fair bit of cable to work with, so it's okay. It has a little bit of holding force, 150 grams, or in other words, 15 micrometers, or millimeters, so 2 ounces of force per inch. Not a lot of force, but then again, this is a hobby stepper. They make them a lot bigger. And then you get into, basically, it gives you the impedance per winding, which is the resistance. It's measured in impedance since it's a coil. Now, so this is what the basic specs are on this item here, and they show you a little bit more detail. And there's the motor connections. There's basically a red lead that's common to both sets of windings. These are split, so it really creates 4 steps of winding. There's a pink and orange, a yellow and a blue wire connected to it, with a red wire as the common. And that's the way the motor is configured. So that's everything right there. So there's your whole setup. There's your electrical. There's your red common. Goes to the center of both coil windings. And all that means is a common tap. These aren't actually laid out 2 on one side and 2 on the other. They're actually laid out in 4. The 4 sides, the real coils. They're just wired this way. Just to let you know. So basically, like I said, this is everything here. The big thing is it's gear reduced, and it's going to go a lot slower than what you would think it would go, and that's actually a good thing. So let's work with this and see what we can do. So let's go on to our main page. So in our main page here, we have our stepper motor. We're going to look at the Arduino. Like we have been in here, we're going to talk about our Arduino programming. So let me just turn that on. We're going to start out with a new sketch. This new sketch, of course, we have to save it. We're going to have to give it a name, just like we do everything else. Oh, it got dark outside all of a sudden. Okay. I guess we are going to get some rain or something, or clouds. But anyways, so this is it, our code. So let's save this file. We're going to go File, Save As, and we're going to give this a name for today to get us started. So I'm just going to go up in here and let me get over to my files for the show. Stepper motors. And you can see I've already been doing a few things. I have a few pictures here and everything like that. So we're just going to go in here. We're just going to call this one stepper _1, just to be slightly different than anything else I have. So this is just stepper 1. So this is our basic sketch. I did talk about that we were going to show you how it wires up, so why don't we take a moment and do that? Probably before we get too far along here. So this is our Arduino. There's not much to connect this up. You can see here. Oh, there's one thing that's missing. Oh no. This is the basic Arduino diagram. Let me see if I have. I made up a better one, and I thought I had another one. Where did it go? There it is. There's the picture I want to use for the Arduino. Yeah, there's so many different ones. The other one was the basic one. This is what I am actually hooking up here today. So let me go over this. This is the Arduino here on the left. What I have here is I have the power from the Arduino. So I'm using the 5 volts from the Arduino over to this board here with the ground, and I'm connecting that to my pot. The pot's going to be an input that's going to allow me to adjust the speed both forward and reverse. Then from the Arduino board itself, I'm using 4 wires, and they're going to connect to this stepper board. Now, I don't have an actual drawing of that stepper board, but this represents the 4 wires that go to the first 4 inputs on the stepper board. The other thing connected to this stepper board is we have to bring in power from outside. This is something important when we're looking at these stepper motors. You don't want to draw your power from the Uno, from the microcontroller, regardless of whose microcontroller it is, unless it's designed for it. Because these things could take a fair bit of power. These outputs are very limited on how much power they can handle. We need more power than that. Plus, if you're using a 12 volt version, we don't get 12 volts from our microcontrollers. We only either get 3 or 5. So what we're doing in here is we're going to be looking at these. Here's my connector here with my 5 volts coming in from outside. Comes down here, connects back to the board. This will then use the power on this side of it. So everything on this side of the chip to the right of the chip will actually use the power from external. Everything to the left of the side of the chip will use the power in here. And actually it's just the common lead that is connected together on the 2 power supplies. One from the Uno and one from the external. Always connect the grounds together to give you that common path, because when we put power to these pins, we need it to get back to the Uno somehow. So that's really what's involved here. This particular chip that's on here, there's a couple of different versions of drivers. In fact, there's about 4 or 5 different versions that you'll find. This is one of the most common. This particular chip is called a ULN2003A or AN at the end of it, depending on which model it is. And basically what this is, it's got 7 amplifiers in it. And basically what happens is here is we trigger it here with a small current from these, and it allows the large current to run out to the motor from the other supply. So basically it's like a bunch of transistors inside with a little bit extra circuitry to make it protected. So we can do that in here. So very simple chip, works really well, and can handle the current of this stepper motor here. Anybody who's worked with a 3D printer or a CNC machine, even your inkjet printer, if you have an inkjet printer, the head moves back and forth. It moves back and forth using a stepper motor. And depending on the style of stepper motor, it's either going to be this 5 wire, or as they get bigger, they tend to go to the 4 wire system, back to the bipolar version, which uses a slightly different driver, similar method of making it control. It's just a different intermediate board here, the stepper board itself. So that's what's basically on here. This is what we're going to use today for the Arduino. To give you a quick idea here is the one for the Feather M4 Express. It's basically the same thing. We're using the voltage on the board, the 3 volts here, to get our pot to control our direction. We're doing the 4 connections between the board, the microcontroller, and the stepper board. We have an external supply, and again, that external supply is connected to the stepper board, and our stepper is connected in the exact same fashion it was in the other one. So the only difference here is which microcontroller we do. The programs are almost identical. So, and we'll go over that. So hopefully that helps you with seeing how it's done. So with that said, why don't we get started on actually programming this thing? As always, when we get to the beginning of an Arduino file, I like to put a title in here at the top. So let us go down here. We'll put in an extra couple of lines up at the top. We're going to throw in here Stepper 1 by kingernorth. So this is the start of it. This is the start of your file. This is just going to be the sketch here. And as always, when we get down in here, we want to install any helper files. So install, or actually include, any helper. Gotta learn how to type today by the looks of it. Any helper files needed. Okay. So in this case here, you're going to really like this part. We don't need any. We don't need any helper files with doing this. This is because we're using the simplest method. There are helper files for stepper motors if you want to get very specific, and if you're using a particular driver board, it may require some helper files like that Cricket that I showed at the beginning, or the other Feather motor board. They both, you have helper files that go with them, and that can be used with either Arduino or with CircuitPython. So you just have to load the appropriate helper files in. But for this other board that we're using today, no helper files needed. So we're going to keep it nice and simple. Okay, next thing we want to do is we want to be able to create any objects. Wow, typing is going to be fun today. I can see that. Any objects and variables needed. So we'll see what those are as we go along. And basically we're going to need a few things. We showed in that drawing we're going to connect up some pins. We're going to have 4 pins that we have to wire up from our microcontroller to our board itself. They're represented here by these green wires that are on here. So I have the 4 wires. So what I'm going to do is I'm going to include those. So I'm just going to say integer, and I'm going to call it stepper motor 1 pin. So this is going to be my first pin for my stepper motor, and that one happens to be equal to pin 8 is where I've connected that. All right, and we're just going to go to the next one, integer stepper motor 2 pin equals 9. I'm just choosing spots that are all side by side to make it nice and easy. Integer SM3 pin equals 10. And you can guess where the last one goes. I'm pretty sure you're going to see that it goes to number 11. SM3 pin, 4 pin equals 11. So those are our 4 assignment for our pins. We're going to do our internal pot as well at the same time. So we're going to have the 10K ohm resistor pot or potentiometer. We're going to have that connected. So that's going to be our pot pin. And that's going to be connected to A0. And the other things that we're going to need is we're going to leave it until we figure out what we need, and we'll come back and add them. So we'll just carry on from here. So now we're going to go down here and we're going to have to go into our setup file. So we're going to have to start doing it. Now, remember, we don't have to set up everything necessarily, but I'm going to in this case. So this is just pin mode. This is a standard Arduino command for this. And we're going to take SM1 pin. So in other words, our first pin that's connected to our motor. And we're going to connect it as an output. And we're going to say that. Now, I'm going to make my life easy. Since my typing seems to be not being the greatest today, I'm just going to go there and I'm going to go paste, paste, paste. And I'm just going to go back in here because this is just pins 1, 2, 3, and 4. I'm just going to go down here and adjust these. So I now have 4 outputs set up. I am going to add one more item on here. And I'm going to add my serial.begin because I'm going to use my monitor. I want to use that serial monitor so we can see what's happening in the program. And I know I'm going to want to add that, so I'm going to go ahead and just do that now. And then that way I'm ready for when we start testing. So this is the first part here. So what we've done at this point, we really haven't done a lot. We've set up our pins. We know we have 5 pins that we need, 4 as outputs, 1 as an input. We have the pot pin and the 4 pins for the stepper motors. We're going to set those as outputs. By default, the analog ports are input ports, so we don't have to put that in here, or in there, and we've included our serial monitor. We've kept it nice and easy. So now what we're going to do is we're going to make sure that we can read our pot value. So that's what we're going to do down here in the main loop. I'm going to go over here and I'm going to highlight this, just get rid of that. And we're going to go ahead and throw in the pot value. So when we do the pot value, we're going to have to come up with the raw value. So we're going to have to read the input. So let's do that. So we're going to have to add that variable up top. So we're going to read the pot, And when we read the pot, we do an analog read. Remember that, because we are doing an analog value. It's going to be a variable value that we're reading in. It's not just true or false, on and off. And we're going to connect that to the pot pin. So that's going to bring in our basic value. So when I come up here under pot pin now, under my variables, I'm going to have to add an integer for pot raw, and I don't have a value for that, and I don't really need one. So we'll just put it in there, and it will assign that value when it gets to here. Now, hopefully you remembered. What value do we get when we read in on an analog input and on an Arduino? It actually goes from 0 to 1023. So that's quite a big number to be working with for what we're going to be doing today. So I think I'm going to remap that value. We've done mapping a couple of times in the past. And I can just put in here a variable that's going to replace pot raw, which is now pot value, equals map is our function. And it's going to take the pot raw. It's going to take the value from 0 to 1023, which is the input, the raw value inputs. And we're going to rescale that to 0 to 100. We're going to use a smaller range. So that's all I've done here is I've just taken that and it's going to rescale that because I don't need the exactness of the pot being so many points, 123 points. I'm actually reducing it by quite a bit. But I did add a new variable in here. This is also an integer. We need to add that up here. So let's put in another integer for pot value. And you can see that this is how we build up our variables we need in a program. So at this point, we're pretty good. The only thing I want to do here is I want to know what that pot value is going to be. So I'm just going to come here to the end of this, and I'm going to add in a serial print. LN, because it's a line feed. Actually, you know, we're not going to put that in here. We're going to do it this way. And I'm going to go in here, put in my quotes, and this will be pot value, end quote, close bracket. Got to put in all the stuff we want here. Serial.print. And this time we're going to go with the LN because we don't want to do a line return after this. And this is actually going to be the pot value. So if everything is working right at this point, on our serial monitor, we should see the pot value come up. And as we adjust this pot on here, we should see that happen. Now it's roughly in about the middle right now. And we'll explain what that gets to. So here, let's just stop here and let's check our program. Before we get too far along, we want to test this. First thing I'm going to do is verify it. It's compiling the sketch. And we're still compiling. Oh, actually, that was the wrong one. Let's try compiling this one. Gotta watch where I'm clicking. Okay, so it's compiled. Now what we want to do is we want to save it. So let's have a look at our tools and make sure our Arduino is connected. It is. It says to Arduino Uno. So let's go ahead and upload that. We're going to compile that sketch. It's uploading and it's done uploading. I'm going to open up my serial monitor now. And I'm going to bring that over so you can see it. I'll bring that way over to this side. And we can actually see that going by there, we have those values. And it says it's about middle right now. I can actually adjust that down towards 0. I'm turning it counterclockwise. It's at 0. And as I turn it all the way up clockwise, it should get back up to around 100. And basically there it is. And I'll bring that back down and I'll put that back down around the middle. There's a reason for me to go to the middle, which I will explain shortly. So there it is. So we actually have the pot working. And that's always a good start to know that something's happening before we actually try to drive our motor. Because we're not actually driving the motor yet. So now from here, we need to start adding in some of our controls so that we can make this thing happen. Well, I'm going to talk to you about how the stepper works. And we're going to do that by, we're actually going to create a little helper file with us. we talked about subroutines. And we're going to need a subroutine for this here. So the best way to talk about this is I'm actually going to describe it, what we want to have happen. How to make a stepper motor move. Because it's not like a standard DC motor where you just throw some power at it and it goes. It's not like that at all. So we have to create some commands. We used 4 pins for a reason. So we're going to call this step move. Nice simple little start to our sketch. And this is going to be our subroutine. So in fact, actually what I'll do is I'll put in here, let me put in here, subroutine to make the stepper move. And the beauty of this is that it won't matter which direction we want it to move. It's going to be the same subroutine for both directions. It really won't matter. So what we do is we do it this way. I'm going to create a function called ifCounter. And basically that's what I'm going to be checking for. And I should put a bracket in front of that. It just makes it happier. So ifCounter is equal, so a double equal sign, I'm doing a compare, is equal to 1. Then I want it to do something. And I want it to do the following steps. What I want to do is I want to set my 4 pins. They're all output pins, so I'm going to do a digital write, and I'm going to write to SM1 pin. So here I am taking it to the first pin, and I'm going to set that to low. And I'm going to need to do this for each of the 4 pins, so let me just do a copy and paste, and then adjust it as I need to. So these 4 pins here, this is going to be pin 2, pin 3, pin 4. In order to make a stepper motor move, one of these has to be set high. In other words, it's going to be putting power out, and we're going to see that with the LEDs that are built into the board. So I'm going to start out by making the top one, and this all has to be in capitals. It goes to the cyan color. And that cyan color tells me that it is a defined variable inside the program. It's a keyword. So what I've done here now is I now have 4 digital writes if my counter happens to equal 1. Well, that means it's going to energize the coil that's connected to pin 4. But pins 1, 2, and 3 are going to be off. And the way the stepper motor works is you energize 1 coil at a time. And if you do them in sequence, it moves in that sequence towards that direction of whichever one you're turning on. So you can do it by going in one direction, like for instance going from 4 to 3 to 2 to 1, it'll go one direction, either clockwise or counterclockwise. But if you went from 1, 2, 3, and 4, it would go in the opposite direction. So we're going to start with this here, and I'm going to duplicate all of this. I'm going to copy that whole section. I'm going to come down here, and I did do what I didn't want to do. Let me do that again. We need to make sure we capture that closing brace as well. That brace matches this brace. So let's try copying it again. Now when I go down here, I'm going to paste it. I'm going to change this counter now to a 2. And over here, I'm going to change this one to high. And this one to low. So I've altered the outputs. Okay, and then we're going to come down here. We're going to do this again. We're going to make that the 3rd count on the counter. So this time we're going to make the 2nd pin high. And we're going to make the last pin low again. And we'll do that one more time since we have 4 wires we need to connect to, 4 different pins. And this time it's going to be a 4. And this one, the first one will be high. And this one will be low. So that's our subroutine. Basically in here, when we jump into our subroutine, we say if the counter is equal to 1, turn on pin 4. If the counter is equal to 2, turn on pin 3. If the counter is equal to 3, turn on pin 2. If the counter is equal to 4, turn on pin 1. And because we are going from one position to the next, when we go high, we have to make sure we turn the others low. Even if they were low before, we want to make sure they're low this time so that it doesn't give us any problems. So we're just as easy to set all 4 pins each time, and we'll get our pattern. And it'll be nice and simple to work with. So again, let me just validate this. I want to make sure I didn't take any typing errors. I did. And it says counter was not declared. Hey, there's another variable I got to add to my variables list. We didn't include counter. So let's go back up and let's put counter in. This is a good reason why to do this. This again is just an integer to make it easy. If you want to be a little more efficient, you could actually make it smaller than that, but an integer will work fine. And we're going to give it a starting position of 1. This one we do want to give it a starting position because by default it would be 0, but we want it to actually have a value from 1 to 4. So we're going to give it the counter is equal to 4. Okay, so that's everything that's in there, which is nice. Let's validate again. When we do, we shouldn't get the orange bar across the bottom this time. We didn't. It compiled. So it's happy. So let's go back to our main loop. This was our subroutine. So that's going to be what's going to be we're going to call. So let's figure out when we're going to call this. This is what we need to do. So in my main loop, I need to have 3 different conditions that happen. And I'm going to explain this a little bit before I get typing too much. Is we're looking at, we have a range that we can read from 0 to 100 is the determined value that we can adjust with our pot. And what we're going to do is when we're going to approach 0, which if I take this pot and I turn it counterclockwise, so all the way down to the left, it's going to be at 0 input. When it's a 0, I want this motor to be turning counterclockwise from the way that I see it. So from 0, it's going to be moving at its fastest rate when it's at all the way down to 0. As we approach the center, it's going to slow down. When we get to the center, I want it to stop. And when I roll this to clockwise, so it's all the way to the right, and the input is 100, I want it to be going full speed, but clockwise instead of counterclockwise. So we're going to have to go to the middle first. And this is something we can look at. We can look at doing this any number of ways, but let's put in the middle here. So we're going to say if, and I'm going to need a couple of brackets here just because I've done this before, I know that it is. I'm going to take the pot value, and what we're going to say, if the pot value is, let's say, greater than, so we'll use a greater than symbol, and we're going to say 44. What we're doing is we're going to create what's referred to as a deadband in the middle of our pot. So basically from 45 to 55, I don't want this thing to move when I'm adjusted on the pot from 45 to 55. I could say 50. The problem is it's hard to adjust from 49 to 50 and to 51. So I'm giving it a range, so I just have to be approximately in the middle. I'm going to give myself some leeway. So what I'm going to do there is I'm going to go bracket, but when it's greater than 44, but it also has to be less than 56. So we're going to use the ampersand, which means and. It's a Boolean and. And we're going to take this pot value, and what we're going to do here is we're going to say pot value less than 56, and we can put in our brackets. And then what we're going to do is we're going to create a small little subroutine in here. Well, the beauty of this is we are going to write to all those pins. Remember I copied and pasted all that stuff down below? Well, I get to paste it in here again, except I'm going to get rid of the if statement that's in here because we're already using one. Where'd my cursor go? There it is. So let's get rid of that. We'll get rid of the extra ampersand. Oop. Sorry for jumping around there. So this is our statement in here. And what we're going to do is we want to make sure all the pins are turned off. So I'm just going to say I want all 4 pins low when I'm greater than 44 and less than 56. So in other words, from 45 to 55, turn off all the pins. That's going to be the easy part. Now what we need to do is we need to do, what if it's not within those values? Well, let's create some samples to figure out what's going to happen here. So if, and in this case, we're going to say pot value is greater than 55. So in other words, when it's 56 or more, and we know it can only go up to 100, we're going to do something here. So we're going to create this if statement. So this is when we want to turn clockwise. So what we want to do is we want to jump down to that step routine down here. We want to jump down to this step move. And we want to go here and we want to do one of those 4 actions based on the counter value. Well, we haven't even put a counter in, although we did have a counter at the very beginning. We know it's equal to 1. So by saying this, if it's greater than 55, I want to go to the step move, and I'm going to call that subroutine. When I go down to that subroutine, well, the counter is equal to 1 by default. So pin 4 is going to turn on. That's the default value it's going to go to. But next, to continue, we want it to go to the next position, which says, hey, I want to go to pin 3. So if it's at 1, actually what I want to do is I want to go all the way down here to pin counter equal to 4, because I had to figure out which way was clockwise, which way was counterclockwise when I was doing it. So I'm going to give you the benefit of the doubt here for me. So I'm going to say counter, and I'm going to go minus minus. Now, what minus minus means is to decrease by 1. Well, so I can decrease the value by 1. The problem is that what happens when we get to 0? So we're going to come in here. We're going to be moving it. It's a value of 1. But if the counter is told to decrease, it's going to drop from 1 to 0, which is outside of our range. So we're going to have to do something about that. But we're not going to do it in here. Actually, we're going to do it outside of here. So what we're going to do is we're going to come down here, and I'm going to move outside, and I'm going to put in another if statement. So I'm just creating a bunch of ifs. So nice simple if statement. If counter is less than 1, in other words, if it's 0, minus 1, minus 2, minus 10 for some reason, anything below 0, I want it to change, and I'm just going to say here counter equals 4. So I'm just going to set it so it's rolling through there. So I subtracted 1, I went to 0. Well, I can't set the pins based on counter 0, but 4 would be in that direction. That's going down. It's going to loop around through the set. So that way it will go to 4, and it'll go to 3, to 2, to 1. It goes to 0, so it resets to 4 and continues on. So that's how we fix that. So far, so good. We can actually see that that's happening, but we don't have any time variables in here. There's no delays or anything like that. So we're going to have to add some delays in here when we're finished. And what we're going to do is we're going to see where that falls in. Because what's going to happen right now, it's going to go screaming by. If I do this right now, it's just going to scream and scream and scream by. So I'm going to build up one more value here. I could probably test this. It would be tricky. In fact, if we want to test it, let's see what happens. I'm going to add in for the values going in the other direction. We're going to see what it does. So let's find out. Sometimes this is how you learn, and I've had to do this in the past. So now if it's less than 45, what I'm going to be wanting to do here is I'm going to be doing step move again. I'm going to call that same command. I'm calling the same subroutine, but this time instead of counting down on the counter, I'm going to count up, and it actually can do that through plus plus. But what's the problem I'm going to have here? Well, when I get over 4, if it comes in as a 4, it's going to go to 5. It's got to go down, so I can just add another if statement outside of here. If bracket counter is greater than 4, then counter is equal to 1. And basically, I don't need the bracket. Let's get rid of that bracket. There's no bracket on the other side of it. Let's validate this. Let's see if it's got any hiccups at this point. It says it's fine. Shall we see what happens? Let's give it a try. I haven't tried this this way, but we're going to try it. We're going to take it there. I have a feeling I know what's going to happen. I think so, but we're going to test it. So you can see, oh, right away, let me get there. I'm in the off position now. So what I'm going to do is I'm going to move it, but I can adjust this anywhere on that right-hand side. And today, when I'm on the right-hand side, it seems to be going counterclockwise. I'm actually in the opposite direction. We'll stop it. We'll turn to the left. Now it's turning clockwise. But we can see those lights are flickering really fast. And we can see that this is going here. But there's really no delays in here. In fact, if we look at the serial monitor, there's our pot value. I get no difference in speed all the way until I turn it off. And then when I go the other way, it goes the other way. So for some reason today, I'm not sure why, but it's wanting to go the other way. So because these are in the wrong direction, if I'm going clockwise, I want this to go clockwise. I want this to turn the other way. So let's fix that. So we'll stop it there. How do we fix that? It's pretty simple. This counter minus minus, what we're going to do is we're going to change that one to plus plus. We're going to come down here and change this one to minus minus, and let's do that again. So let's upload that. And we're going to step the other way through the program. So now what happens here is while I'm going there, now I'm clockwise, it's going clockwise. I'm actually getting what I want. And if I go down here, and I get back here to the middle, and I go to the left, counterclockwise on the dial, goes counterclockwise on there, so it actually matches. So that's really nice that I can get it to match. And that was a pretty easy change, just changing whether I count up or count down. By not putting these two limiters inside of the two values, where I'm actually doing the counting, I can actually, it doesn't matter, it's a very quick, easy fix to make that change. So now we're going to make another change, because one of the things is we don't have any speed control yet. At this point, we are running strictly on what happens when we do this. So what we're going to do is we're actually going to create a little bit of speed control, because I want to be able to slow this thing right down to a crawl. So what I need to do here is I need to be able to put in a value here. So we're going to put in a delay time. So I'm going to come up here and I'm going to put in a delay after increasing the counter. So I'm going to put in something called delay time. So this is going to be a new variable. We don't have this variable yet, do we? So you know what? Before I go any further, what am I going to do? I'm going to come up here and I'm going to add the new variable in here. So this is just going to be an integer because it's going to be a small value. Delay time equals 0. We're just going to start it out with, actually, believe it or not, I'm actually going to start out with a raw value of 500, half a second, if I'm not doing anything else. So my delay time, I'm going to change it here though. I'm going to make delay time equal to a particular value. And what I'm going to do in here, whoops, is I'm going to actually do a little bit of math. I'm going to take my pot value of 100, and what I'm going to do, that's my maximum value for my pot, and I'm going to subtract from it whatever the actual pot value is at this point. So there's my pot value. Okay, and then what I'm going to do is I'm going to add 2 to it. And the reason I'm adding 2 is I just don't want it to be 0 all the time. in here. So I want at least a couple of milliseconds because we're going to put in a delay time here in this thing here for our stepper. So what I'm going to do is I'm going to create, so the time variable for delay time is going to vary from 2 milliseconds. Remember, my maximum value is, if it's greater than 55, so 56 is as big as it can get, or as small as it can get. So at 56, this is going to be 44, plus 2 is 46. But when I dial it all the way up to 100, it's going to be 100 minus 100, which is 0 plus 2, it's 2 milliseconds. So I'm actually going to shorten the time in between each of these steps. And where I'm going to throw these all in is I can actually just put this in at the end of my program down here. Just at the end of my loops, I'm going to come down here and I'm going to put in my delay, our regular standard delay, but this is going to be delay time. So it's going to take that value that I just created up here, up on rung 41 for the clockwise direction. It's going to take that value and write it into here, and that's how much it's going to slow down the program by. It's a pretty small delay, but it'll be noticeable when we get into getting fine control. Well, we need to put a similar formula in for counterclockwise. It is a slightly different, but we're going to put it in, and I'm just going to show you what that formula is. So this is just delay time is going to be equal to, and in this case, we're dealing with the lower value. So we're going to be only starting with the maximum value is only 45. So it's 45 minus, and then in order to get it to go the right direction, we need 45 minus the pot value because we need to inverse the number. Pot value. And we're going to put in another bracket there, and then we're going to go again with the plus 2. So what happens in this case here is we start out with the maximum value, which is 45, and then what we have to do is we have to subtract our current pot value. Well, as we get to 0, that's our fastest. So it's 45 minus, and then in here, 45 minus 0 would be 45 minus 0 would be 45. So it'd be 45 minus 45 plus 2 is 2 milliseconds at the fastest value. At 44, it's going to be 45 minus pot value, which is 44, which is 1. The 45 minus 1 is 44, plus 2 is 46. So we actually have the same range. We go from 0 to 46, or 2 to 46 on our delay, regardless of which direction we're going. So that just makes our math work for us. So those are our two math formulas, and we've added in this delay. The only thing we're missing is, what is the delay going to be when we're here? So we haven't set here, we can set a default delay value. So I can just say here, delay time equal to, and I'm going to say here, we're going to, if we're stopped in the middle, we're going to say, hey, every quarter of a second, check it to see if I've moved the pot. Otherwise, don't bother. So we're going to say we're going to give it 250 milliseconds when we're in the middle. Now up here, we went with pot value. Down here, what we're going to do is I'm now going to take those values out of here. I'm going to cut those out of our program. And I'm going to bring them all down to the bottom because I'm going to add a bit. Where's the bottom? Here's the bottom. Let's go right in here. And just before we put in the delay, what we're going to do is we're going to go pot value. And then we're going to add a little more comment just so we can see what's going on. Serial.print. And we're going to put in another little comment here, quote. And this one, oh, this one will be comma space. And this is the delay. We're going to go like that. And then we're going to actually put in that delay time. Serial.print. And this is the ln now because this is the new end of the line. And this will be the delay time. So we're going to see what the two values are and see how they move together so we can kind of understand how they work. If this is all good, we're going to verify. We're going to find out. It looks good. Let's compile it. And we're compiling and saving out to the Arduino board itself. Let's pull up our serial monitor. And I'm going to have to move this over a little bit, but that's okay. We can now see it. So we can see right now with our pot being near the middle, our delay is at 250. As I turn it counterclockwise, my delay is shortening down, and you can see I'm starting to move in small steps. And as I pick this up, it's going to move faster and faster and faster until I get up to full speed, which is a delay of 2 milliseconds. So I can actually turn that thing at its relatively full speed. And then what I'm going to do is I'm going to bring that back down and slow it right down to a crawl. And I'm going to start moving it the other direction. And we can see that our delay is still shrinking as we increase. And we get up there and we are now back to turning. So where you could use something like this is you could use this to control a turntable manually. You can actually get in there, hook it up. If you wanted to get even finer control, you can actually speed this up a little bit faster if you smoothen down the program a little bit, and instead of milliseconds, go into microseconds for controlling your delays. You can actually get into finer values, and you can actually make it run smoother. So there is ways to improve this, but this is a good start. And to see what's happening in here, as I slow this down, if I get this down slow enough, you can actually start seeing those lights. Hopefully you can actually tell that the lights are moving in one direction. When I come to the middle, they stop on that board, and when I start just into the other side of it, they're moving in the opposite direction. So that gets us our basic control. So we can see that we can actually get some pretty fine control from this little stepper with a nice simple program in Arduino. And like I say, you can improve this and make it a lot better too. So hopefully that helps you out. Hopefully that'll answer some questions. What I'd like to do is I'd like to go on to showing you the CircuitPython version and explaining how its program works. It varies ever so slightly. So let me just stop this moving, and I'll move this one out of the way. I'm going to bring the other one into the image. Let's see if I can get my wires to bend around here somewhere so they don't hit. And it looks like it's there. I'm going to change images here on the screen, so let me turn that one off and turn on my Circuit Playground version. So up here at the beginning, this is all our same type of thing. We start out with some comments at the top. So I'm starting out here with Stepper Motor Test by kingernorth. And this is just letting me know what I did. I'm importing all my files. Now for this one here, I've actually imported time, board, digital I/O, simple I/O, and math. They all come from internal from the program. And so does analog I/O. So there's really no big differences here. Analog I/O is about the only one that's maybe external. I think that's an external file on this one, a library. The others are already built in. Actually, analog I/O is built in as well, so there's no actually extra pieces. Here I'm creating my pin assignments, just like I did in the other one here. I have SM1, SM2, SM3, and SM4, exactly the same, and pot in instead of pot raw. But again, that's my analog board. I'm going to pin A5, and this one I used digital pins 9, 10, 11, and 12 as the output pins, which are the green wires up here, same as what we did before with the green wires. I'm going to create my subroutines. You create them first in CircuitPython as opposed to at the end with Arduino. This is the same type of thing. So I have, it's just called count. Originally I had two separate counters. I had one for clockwise, one for counterclockwise. I should have changed these to counters, but I didn't. I just left it as counter CW. Again, this is the same thing that we did before. False means they're off. True means that it's on. So it does the exact same thing as we had before. We start out with a default value for counter of 0. We start with a stepper delay of 1. In the program, this is our program. It looks long, but a lot of this is comments. So I'm going to try and read through some of this. So while true, I'm going to bring in my pot value and I'm going to remap it. This is just the way it's done in CircuitPython. It's a little bit longer because I'm actually using the math truncate to get rid of any decimals. I'm doing simple I/O map range. I'm taking in my pot value. I'm picking the range. Since it's a much higher resolution, I'm actually taking a range from 1000 to 62,000 on the input. And I'm mapping it out to 0 to 200. So same basic idea. Okay. In here, I've got if my map value is greater than 89 or map value is less than 111, then I do my step value of 0.1, which is 100 milliseconds. And then what I say if it's over 110, so I've created a dead band from 90 to 110. If I do it here, I do a step move and I do +1, and then I figured out my map delay based on all of this and turned it into a decimal value. And in here, I wanted a minimum of 2 milliseconds. So I'm just adding the 2 milliseconds onto the end. But I'm actually figuring out my map value minus the map value divided by 1,000, and then all done there. So that works out. I do the same thing for if I'm less than 90 for counterclockwise. If I'm between those map values, I just turn them all off. Nice and simple. And if my counter goes higher than 3, set it to 0. If my counter is less than 0, go to 3. So in this case here, I did counter 0 to 3 instead of 1 to 4. Does the same result in the end. I have a time sleep and I have a print for doing my delay. If I open up my serial monitor, we'll see that my delay is at 0.1 right now because I'm in the middle. As I turn it left, I get it going counterclockwise. And you can see my delay is showing my milliseconds are lowering down until finally I get to 2 milliseconds. Now you can see here without all the extra stuff working in the program how fast 2 milliseconds actually is. There's a few things that are slowing it down on the Arduino side, and the main thing is that printing to the screen. If I turn that off, my stepper motor would run faster. This one, it's less intrusive on it. So you can see I can actually turn at a fair bit of speed, but as I increase that time, I can start getting a fair bit of control out of this thing. And I'm getting close to my times that make any, in fact, I'm in a long time here. I'm actually getting down into close to 0. I'm still creeping ever so slowly, but I can bring it back up here to the middle. My lights go out, tells me that I'm stopped and I'm not putting any power on the motor. So all the windings are off at this point, which means the motor's not going to overheat or anything else like that. So now I can turn it clockwise and we can see that it starts speeding up. Here I can get those steps down pretty slow. You can see, if I move that out of the way, you can see those LEDs are moving in a pattern. If I go to the other side of center, you can see that pattern goes in the opposite direction. So we'll go ahead and we'll speed it up this way. And again, as we speed it up, you can see I can get into a fairly quick speed here. And that's again at that 0.2 or 2 millisecond time delay. This is a much faster chip than the Arduino, so I can actually achieve higher speeds out of this chip. That's just one of the advantages of using the more modern chips. Arduino also has faster chips. And of course, you could program this chip, this board that I'm using for CircuitPython, you could program it for Arduino as well, which would help speed up the Arduino sketch. So there's a lot of things you can use on this. They're both done basically the same way. And we have pretty good control over this. So it's not a hard program to go through. Basically what you want to do is you want to take your pot. The basic steps are take your pot, remap it into a more usable range, because the inputs are usually much higher range than what you really want for something like this. Then what you want to do is you want to create your step pattern, and that's what's created in the subroutine. In either case, it was created in the subroutine, doesn't matter which program. Then what we do is as we move the pot, we give it a dead band in the middle where we don't want it to do anything because it's hard to get an exact figure on an adjustable pot. So we give it a fairly wide dead band of 10 or 20 counts, depending on our resolution that we decided on. And then what we do is, as we turn it to be intuitive, if I'm turning it counterclockwise, I want the dial to spin counterclockwise. If I'm moving it clockwise, I want it to move clockwise. So I want them to match. And as the further adjustment from stock you make it, the faster it should go. Just do the math to make those counts faster. But you can see by adjusting the count rate, we can adjust how fast that motor goes, and we can stop it in any position. If I wanted to stop it in the straight up position, I could go here, advance it, adjust it here, and then I could say, okay, that's about where I want it to stop. Whoop, there, a little too far, back it up. There, I'm happy. So I can have it go straight up without any real problem. So you could use this, connect it to a turntable on your train layout, and manually adjust your turntable without having to reach across the layout and turn the turntable itself. You could just power it with a single pot and make your turntable move when you want it to. You could always add a switch to make sure that the turntable doesn't move when you don't want it to, or things like that, by cutting this power going out to the board. Because I'll show you right now, we know that that makes it go. It is not using the power from the microcontroller. It's actually using it through this other plug that's up here just off the screen. If I unplug the power to that board, it stops. So if we were to interrupt that power with a switch, we could make sure that somebody didn't accidentally leave the dial in the middle and turn it on. So there it is. There's a nice little simple project. I'm hoping that you can get something out of that. So this is how we make stepper motors. In fact, just to let it go while we're doing stuff here. Let's just make it spin. So as our time is up, we've gone through an hour now. We can see what happens in here. It doesn't matter whether we're using CircuitPython or whether we're using Arduino. We can make our motor controlled. We can actually delay it. We can get very tight, very good precision on it. Think about it. We have 512 indicators in there, and we have a gear ratio of 16. So we actually have very, very, very fine resolution on this motor. There are more detailed motors, the ones that even move finer, but then they have slower overall RPM. So you have to find the trade-off. I have one of these connected to my turntable. I'm running it with CircuitPython, not with the pot though. I'm actually automating mine. But I get about 8,000 counts for a full resolution on my table. And I do that because I have it geared down from here, from my stepper drive, I have it geared down even more out to my turntable itself. So I actually get really fine movement on it, and it allows me very fine adjustment around my turntable to make sure I line up with my tracks every time. Yeah, it's another thing. You know what? These things are great. You can do all kinds of animation with them. You can do lots of fine control. You can move. We've done 3 types of motors now, if you think about it in these lessons. We started out with servos, both continuous and angled servos that only have about 180 degrees of movement. We talked about DC motors, and now we've talked about stepper motors, and they're all a little different from each other. So depending what you want to do, you just decide which motor works best in your application. All right, so that's it for today. I think we're going to leave you on that. I'm going to say thank you very much for watching this program. This has been Microcontrollers with kingernorth, episode 16, stepper motors with CircuitPython and Arduino. Thank you. Remember, you can follow me on Twitter to get notices of when these things are going to go out. I always Twitter out when I'm going to notice when I'm going to go streaming live. And that's at kingernorth on Twitter is my handle. And on YouTube, you're obviously watching this channel if you're watching this now. But this is youtube.com/kingernorth. Make sure you subscribe and turn on the notices. That way you'll get the notices when I'm getting ready to stream as well. I tried to put it up ahead of time, and you'll get a notice the day before telling you that the stream is coming and something about it. All right, till next time, enjoy yourself, stay safe, play with your electronics, get better and better at it as you move along, and have fun. Bye, everyone.